Let's ride a wave, diving into the science of light and sound waves with physics. The author's name is Chris Ferry. It is part of the Everyday Science Academy series. Let's ride a wave. What a perfect summer day to be at the beach. Red Kangaroo loves watching the waves. It's so relaxing. I wonder if the waves ever stop, she thinks to herself. I'll ask Dr. Chris. Dr. Chris is in his lab, setting up several things on a table to help answer her question. The waves never stop, he says. Nature makes all types of waves in so many different sizes. All of these things make waves too. Really? Red Kangaroo asks. I guess I need to learn some wave physics. First, let's start with the definition of a wave, Dr. Chris says. A wave is any repeating pattern. When we measure the space between each high point, that is called the wavelength. Oh, I get it, Red Kangaroo exclaims. So some waves will have short wavelengths and some have long ones. That's right, Red Kangaroo, Dr. Chris replies. Let's go back to the beach to investigate. Ocean waves are an example of waves you can easily see in nature, Dr. Chris explains. The wavelength of these waves could be about as long as a football field. If we waited long enough, we would see that the whole ocean itself rises and falls twice each day. I know, Red Kangaroo interrupts. That's called the tide. That's right, says Dr. Chris. The tide is a wave with a wavelength the size of the Earth. When they get back to the lab, Dr. Chris shines a laser on the wall. Is that light a wave too? Red Kangaroo asks. Yes, all light is a type of wave, Dr. Chris replies. And each color of light has a different wavelength. But why can't I see the wave? Red Kangaroo wants to know. You are seeing a wave, Dr. Chris says. Light is a type of electromagnetic wave. Electromagnetic waves travel through space at such a fast speed that it's hard for us to recognize them as waves. Electromagnetic waves can have very different wavelengths, Dr. Chris continues. Some of these waves you can see, like visible light, and all the colors light helps us see. But there are also electromagnetic waves that you can't see at all. There are waves I can't see? Asks Red Kangaroo. Can you teach me about them? One type of wave we can't see is the radio wave, Dr. Chris says. These waves are really long and have the length of a house or building. Radio waves help us send and receive messages to communicate. And they don't only work for radios, but also TVs and cell phones. Wow, so that's how I can get a call on my cell phone? Red Kangaroo says. Another wavelength we can't see is the microwave, says Dr. Chris. These waves are smaller than radio waves and are often used for cooking. They bounce around to make my hot chocolate warm. Yum, says Red Kangaroo. Now, let's talk about the waves that have wavelengths smaller than visible light. Dr. Chris says, ultraviolet light comes from the sun. We can also make ultraviolet light to grow plants indoors. I've heard of this wave before, Red Kangaroo says. It's also called UV light. We have to wear sunscreen to protect our skin from UV rays. And you probably have heard of X-rays. They have wavelengths even smaller than UV light. Dr. Chris continues. X-ray waves are useful to see inside things because they can travel right through your skin, but not your bones. You can find them at your doctor's office, hospitals, and even airport security. Wow, electromagnetic waves are amazing and so different, Red Kangaroo says. Are there more types of waves, Dr. Chris? Yes, there are, Dr. Chris replies. Sound is made of waves that travel through air. You can't see these waves either, but you can hear them. But I thought light waves travel through the air too. What makes sound waves different? Red Kangaroo asks. Great question, Dr. Chris replies. Water and light waves go up and down. We call them transverse waves. But sound waves go in and out and are called longitudinal waves. You can tell the wavelength of a sound wave based on how it sounds, says Dr. Chris. Think about the sound of a drum or noise from construction work. Those are low sounds, which means they have long wavelengths. Now think of the sound of a whistle or birds chirping. Those have high sounds and short wavelengths. Wow, Dr. Chris, I've learned so much about waves today, Red Kangaroo says. There really are waves everywhere.